So let's review a little bit of functions. If we were given two different functions, f and g, then we can easily find their domain um, by taking the domain of f and taking the domain of g. So if I have two functions and I wanted to add them together, subtract them, multiplying or divide them, then I can easily extract their domain by taking the domain of f and the domain of g and then finding what they both have in common, like I did here in this blue shaded region. So this blue shaded region is actually the domain of all of these, kind of. Because if I, for some reason, wanted to find the domain of f of g of x, well, remember that g of x cannot be 0 because we have g in the denominator. So we need to check when does g of x equal 0. So there's an additional step that we got to do. So let's do an example. You saw that when we added, subtracted, multiplying, or dividing, it wasn't really that bad to go ahead and do the computations. So we're just going to look for the domain. So let's say we have f of x equals, I don't know, square root of x. And let's say g of x is equal to x minus 3. Okay, so let's say those were my two functions. And what I'm interested in is finding the domain. So find domain of all of these functions. I'm not going to write them down. So f of f plus g, f minus g, f times g, and f divided by g. Okay, so we're going to find the domain of all of those. So the first thing that we want to figure out is what is the domain of f. So we see f of x is equal to square root of x. And whenever we have radicals, remember that we want to make sure that it's positive. The radicand inside here is positive. So we want x in this case to be greater than or equal to 0. Because it can also be 0. The square root of 0 is just 0. So when I write this in interval notation, we're just going to get 0 to positive infinity. Okay? Now we need to figure out what is going to be the domain of g. Domain of g. And the domain of g, well, we know that g of x is equal to x minus 3. Well, g of x is equal to x minus 3 is just a polynomial. And remember that polynomials all have a domain of all real numbers. So here, this one's really easy. The domain is just negative infinity to positive infinity. Okay, so that's what we have. Now, what we want to be able to do now is find the domain of both of them. Okay, so I'm going to take the domain of g and go ahead and graph it in a number line. Here is 0. We know that 0 is going to be included. That's a closed circle. And then everything that's positive is over here. So here is the domain of f. The domain of g now, okay, well, that's all real numbers. So everything here is shaded, right? So the entire number line. So now the domain of f plus g, f minus g, f times g is all going to be where both of these have in common. So if we see between here to here, there's nothing in common, right? So there's nothing here. It starts being alike when it's from 0 all the way to infinity. So the domain of all of these functions is just going to be from 0 all the way to infinity. So this is the domain of these functions. Now, the domain of f of g of x, okay, so let me write that one in red. So the domain of f over g of x, I don't know what I just said right now, but f of g of x. So we need to be able to find what this is. Now we know that it's going to be exactly the same thing, 0 to infinity, but we have to be sure that we check when g of x equals 0. Okay, now g of x in this case was equal to x minus 3. Okay, so when I add 3 over, I'm going to get x equals positive 3. So this is a number that g of x cannot be equal to. Okay, so let's go ahead and rewrite our domain. So this was our original domain from 0 to infinity included. So it was included all the way here. But notice now that x cannot be equal to 3. So at 3, there's actually an open circle. So the domain of f of g of f divided by g of x is going to be all of this, okay? So let's go ahead and write it. So it starts from 0, then doesn't go to infinity, it stops at 3, and 3 is not included. Then we add a union, then we start at 3 again, so I'm excluding the 3 and I go all the way to infinity. So here, notice that the domain is very different than these numbers, right? So sometimes the domain may be a little bit, may be the same thing, but we always want to check g of x. We always want to check that when does it equal 0, and then after that, find the domain, okay? So hopefully this helps a little bit more, and in the next video, I'll do one with compositions.